Okay, hello.
Hello everyone.
Yeah. Jom.
Jom let's Sembang AIoT.
Good afternoon.
Good afternoon everyone. My name is 𝐀𝐮𝐬𝐭. So today with me is CCD. So today our topic is talking about the AIoT and the predictive maintenance. So but before we go into the what is predictive maintenance, we might want to review about why we need the maintenance. Yeah, so when we talk about maintenance, so it must be related to some machine. So something that need to be fixed. So when there is a problem. So when we talk about the industrial revolution, so from the first industrial revolution, so that time people use the steam and water power to mechanize their machine. So when there is a machine operate, so that is a chance for the machine to break down after some time because some of the part it might degrade over the time or wear down. So at that time, when the machine break down, so the factory manager will ask the maintenance team go to carry out the maintenance. So this type of operation, we call it as a reactive maintenance. So when there's a problem, you ask people to solve it. So when there's no problem, you don't need to do anything.
That one is preventive.
No, now we still at the reactive maintenance.
Reactive maintenance.
Reactive maintenance. So when the
That means fire, we go to which place? It's a firefighting how.
Yeah, when there's problem, we only go to solve it. When no problem, we don't do anything. So it sound logic, right? No, nothing wrong with this logic. When there's problem, we only solve it. No problem, we don't do anything. But the problem is, you might observe your OEE will drop because of the unplanned downtime.
Unplanned downtime.
Yeah. So we because we don't know when the machine will break down. So this one is the unplanned downtime. It will cause your OEE, the overall equipment efficiency of that machine drop. Then your productivity also will drop. So when this kind of thing happen, then all the stakeholder, the boss, not happy already because of the OEE drop. Then the factory manager need to do something. So he come out with another plan. We call it as the preventive maintenance. So he instruct the maintenance teams to carry out the maintenance every 3 months. So no matter this machine breakdown or not, they must carry out the maintenance. So every 3 months, they will stop the production. At some time it's not so busy, then they carry out the maintenance. They repair, they do the checking, and then they replace some component. No matter the component need to be replaced or not, they need to replace it because according to that plan, they need to replace the component every 3 months. Okay, so using this method, the unplanned downtime can be reduced. So the chances for the machine to break down now is lesser. But after some time, the factory manager will notice the maintenance cost increased a lot compared to previous reactive maintenance. Now the maintenance cost will increase a lot already because every 3 months you need to carry out the maintenance, no matter there's breakdown or not. Then, but it won't eliminate the chances of the unplanned downtime. The unplanned downtime still got the chance to happen, even though you carry out the preventive maintenance. So now you still have the unplanned downtime. The machine will break down at any time. Just the chances become lesser now. And then your maintenance cost increase a lot. Then the factory manager will come out with the third solution, so which all people are discussing now, the predictive maintenance. So people try to predict when we need to carry out the maintenance instead of we schedule the maintenance. So what the predictive maintenance do is we try to predict when the machine breaks down. Then before the machine breaks down, we schedule maintenance for it. Then Before this, we carry out the maintenance every 3 months. Now, maybe it can become longer, maybe because we know the machine can last for maybe 5 months. Then we let the machine run for nearly 5 months, then we only carry out the maintenance. And this, by using this method, you can reduce your maintenance cost already. And the frequency of inspection, which means before this, every 3 months you need to carry out the maintenance, right? Now it becomes lesser already. And then some of the the maintenance process is not is related to the safety. For example, you need to carry out the maintenance at the wind power plant. You need to ask the maintenance people climb out to the turbine there to carry out the inspection. So this kind of operation is a risk. And then when we carry out the maintenance, it will cause the service interruption, and also there's a cost of interruption. So all this will increase your operation cost. So to carry out the predictive maintenance, there are 3 steps. So to predict it, we need some sensor. We need the sensor to tell us what is the status of the machine now. So first step is to install the sensor. And then the second step is, after you have the sensor, you need to capture and transfer the data. This one is the second step. And then the third step is you need to analyze the sensor data for the failure. So you need to find out, based on the sensor data, the received sensor data, does it showing some abnormality? Are it showing some symptoms that are going to fail? Then after we have all these things, let's say you have to detect the abnormal, then we want to know the RUL. So Mr. Lee, do you know what's RUL?
RUL.
Yeah, RUL stands for what?
Roll. No, sorry. What is RUL?
RUL stands for the remaining useful life.
Remaining useful life. Wow.
So which means after you detect the abnormal, how much time left before the machine breakdown? So sometimes when the abnormal occurs, the machine won't break down immediately. It still can last for 1 week or 2 weeks. So we want to predict this RUL, so the remaining useful life.
Wow, that is a very big words. The RUL, remaining. That is how long this device or how long this machine is going to die.
Yes. How long it still can operate before it dies?
How long before it operates? Then what is this RUL for human being?
RUL, if you use as a human, then how much life is left?
Oh, you're very sad. Okay.
But human one is very hard to predict. Machine one can, based on the sensor data.
Okay.
So far I already talked so many things. I haven't touched the AI part yet.
Yeah. So just to add a little bit, thank you for watching. Today you are watching the 𝐀𝐮𝐬𝐭, less Sembang. Of course, in this this is our, just now we show like that, right?
Yeah.
This actually is our the 11th session. Yeah, we have done it the 11th time. Yeah, this is a challenge. Our challenge is 100 times. 100 sessions. So it's the 11th time. Thank you for watching, and I hope you can do SSL, share, subscribe, and also like. SSL. Why we use SSL is because of the security thing that technical people understand. Yeah. So this is one part. I think today's topic again, Ken has mentioned the predictive maintenance. Of course, in all our sessions, we are trying to bring you something that's legacy, because our technology is moving so fast. So we are trying to bring some legacy thing. Usually, we will find out what are the legacy that we have. Of course, we are going to Sembang about AI, IoT, especially in this topic, we are going to talk about predictive maintenance. So these are the ingredients for you today. Usually, we are hosting this in the weekend near before you go on a weekend holiday. So I hope you sit then and enjoy what they are sharing. Yeah. So Kenan, you can continue from what just now we said.
Yeah. So the predictive maintenance, this concept, I think exists long time ago, right? I think because yesterday I found a book starting from 1990. They already published a book talking about the predictive maintenance. So it's around 30 years ago, but I believe it's more longer, before 1990s years before. So at that time, the AI is not mature yet, and the computer also not very advanced. Internet, I think also not very stable. The speed also is slow. So how the people do the predictive maintenance at that time? So that book they talk about the vibration theory. So this is a book talking about the vibration theory. So the vibration theory is talking about how you're going to analyze the data from the sensor. So based on the vibration, based on the temperature, the humidity, or the voltage, the current, all these parameters. And then, so it sounds like very complicated. It's not easy to carry out the predictive maintenance at the previous time. So you need to hire someone that has a very good understanding in the vibration theory. And at the same time, you also need to, at that time, the sensor also not very advanced. I believe you want to, it's not like today we have a single sensor that can do a lot of things. If you want to measure the acceleration, you need an accelerometer, and then you need a transducer, you need a displacement sensor, or the pressure sensor, different type of sensor, just put on a single machine to collect the data. Today, you just need a single sensor that can do a lot of things for you already. So at the previous time, so people use the different type of sensor, collect the data, and then they even do the FFT.
Fast Fourier transform.
Yes, correct.
Frequency response.
Yes, they need to study the frequency response, the time domain, frequency domain, and then apply the FFT to analyze the sensor data. And for me, the FFT is not something easy to understand.
FFT sound like dirty word. FFT. Okay.
Actually, it stands for fast Fourier transform. It's a mathematical operation to extract some information out. So, yeah, there's a difficult time to do the predictive maintenance. So it also involves a lot of costs. So because you want to hire some expert that has this kind of know-how to do this predictive maintenance.
Yeah, before you go on, I think first FFT that time when we was doing the mathematical what do you call it, this subject FFT, fast Fourier transform. I don't quite like the subject because there are a lot of this integration.
Yes,
integration. We do a lot of integration. But the significance at that time, I was so attracted to that. I was so attracted because we were studying EM wave. At that time. So we a lot of things, especially electronics, it depends. That actually relate to some of the digital electronics, digital signal processing.
Yes.
Digital signal processing during that time, FFT is one of the mathematical concept at that. Yeah. So it's actually doing the frequency response or frequency domain. Yeah. So that is actually got me very attracted to this subject. We try to find the significance of it. Actually, all the mathematical the derivation from the mathematical calculation, all these things is actually relate. It's being used in a lot of engineering field.
Yeah.
Okay.
So based on all these analysis, then at that time I'm not sure this data scientist this term exists or not. So that expert need to decide. So based on this data, does the abnormality occur or not? So actually the decision is still made by the human based on the sensor data. So okay, so there's a problem with this one. When this expert resign, moves to another company, you need to hire another one, and then the new company to study everything again. Need to study all your machine, the sensor again. So this will cost you. You need to spend need to make more investment to make this thing happen. So now we have the AI. So people start using the AI to analyze the sensor data. So you can imagine now today we have this kind of sensor. It can give out 50 parameters. So if you use a human to analyze this 50 parameter, different people might give you different conclusion or different prediction. So, but by using the AI will tell you now it's considered normal or abnormal based on the historical data. So the way how the AI operates is also similar to human. It's based on historical data, but this thing is more stable because we don't have the emotion. It won't be affected by other factors. So in behind of the AI actually is the mathematical operation. So it also based on some fundamental of the mathematics to give you the prediction result. It's not simply give you a random number or a random result. So we can control the result. Okay.
Since you keep on looking at this one, maybe some audience may be very curious about why do we have this setup? Why do we have this setup?
Yeah, okay.
Because from the beginning, people think, hey, how come you are? Actually, we are trying to do some a closer look on some of the sensor later on. Okay, I'm going to show you, of course. Yeah. So just for some of you who have just came in, of course, we like your feedback, or if you have any comment or you have any question at all, maybe you can just put up. At one time, I was asked by one of the professors saying, "Oh, your this live all the live is all recorded live, is it?" It's definitely not a recorded live, it's live. There's no such thing as a recorded live. So that's why we welcome any question. If you are watching this one, we are talking about the predictive maintenance, which is more closely related to smart manufacturing. Yeah, this is one of the big topic, and a lot of people want to know about that. So, of course, how does it relate to AIoT? Today we are going to tell you more about this. Yeah. So,
yeah, now we will share the camera view of this over here. Okay, so remember just now I got mentioned there are 3 steps when you want to do the predictive maintenance. So the first one is to install the sensor. So this is our sensor, the vibration sensor, that can measure the displacement, velocity, the acceleration, and then
3 axis, right?
Yeah, 3 axis.
This guy is having a 3 axis. Why do we need to have a 3 axis?
Why you need to have 3 axis? Because the vibration can happen at any direction.
Different equipment is giving you different kind of direction.
Yes. Okay. And if you want to talk more detail, it will related to the harmonic and non-harmonic vibration again. That one is too technical already. So again, over here we have 2 fans, the CPU fan. So one labeled as the B one is the bad one, another one is this one is the good one. So now we place the vibration sensor on the good one. So the vibration sensor will collect the data and being pulled by this IoT gateway. So you have the gateway to collect the data from this sensor, and then the IoT gateway will use in this case, it's using the 4G, the LTE, to transfer the data to the cloud. So this is our second step, capture and transfer data. So at our cloud side, later on I will share the screen. So there's a dashboard. So our cloud is running some machine learning algorithm to analyze the incoming sensor data. And then the machine learning algorithm will give the prediction whether now the status of this CPU fan is considered as normal or abnormal.
Yeah. So that is the thing. So of course, so right now, I think some of you have been watching us for some of the past. So this same gadget has been brought up before, but I think during the time that we do the shipping at the time, that was very blurred. I think that the resolution is not doing very well. So of course, currently, can you show? Yeah, currently we have two type of data collection point. It can be from a 4G gateway router. It can also come also to our standard gateway. Just now we have just had a meeting with our Taipei colleague. You know, he has been sharing a lot of new stuff. Yeah, new stuff. That actually, before we continue, I just want to tell you, you know, on this 22nd of August, we are going to have this webinar. I hope if you can, you know, it's very quite a technical webinar. Maybe we can show the webinar. So by using this box, yeah, you can design using this box to do all the data collection and analysis. Or this one act as an edge, IoT edge gateway. You know, it has a 2 serial port. You know, even RS-485 with the LAN, with some Wi-Fi interface, and you know, yeah, not this one, the other one. Yeah. Let's look at this screen just before Daniel continue to do so. This is the one that we are going to, you know, tell you more on this 22nd. We are going to tell you more how can you tap on to leverage the power of this IoT edge gateway to do further integration. You know, for example, just now you saw the screen again. Yeah, I saw the screen again. There is such a thing called redfish. Yeah, how can you use redfish? And then how are you going to do the ThinkBot integration with our this box? If some of you already, you know, because these are some of the IoT standard tools, but redfish is quite a new one, so you can tap onto that. You know, REST API, MQTT, up to you. Yeah. So on the 22nd, we are going to tell you more. If you have time, join us on the 22nd. Yeah, maybe we can continue.
Yeah. Okay. Now we move to our cloud dashboard. Okay. So this is our cloud dashboard. So it's showing now it's running the inference. So it's showing the status of the CPU fan. So one means is okay. So this one is showing the anomaly result. So it's somewhere around okay. 0 means normal. 1 means abnormal. So it might be fluctuated. So because there's some strong vibration from our side, when we put our hand on the table, so it will vibrate. So the value might be fluctuated a bit, but it won't go up to 1. So because it's the machine learning algorithm think that it's not considered abnormal because of this tiny vibration.
Okay, look, this one, all the data is live, right?
Yes, it's live.
Yeah, it's actually live to the dashboard. Yeah, it's live to the dashboard.
So there are 2 ways to carry out this kind of machine learning, to run the machine learning algorithm. So today what we show it is we run the algorithm on our cloud. So another way is you can run the algorithm in this IoT gateway. So if the latency is an issue, is something that you concern, then you need to run the machine learning algorithm in the IoT edge device. So if the latency is not something not important, then you can run it on the cloud side. So and then at the bottom we have, I show some parameter. So this one is the x-axis amplitude, the velocity, and the y-axis is the z-axis. So it's for a human, if you ask the data scientist to look at all this graph, and there are 50 parameters, so it is not easy to identify at which point the abnormal occurs. Just need to make comparison of 50 graphs. So we let this kind of heavy job, we let the AI to do it, and AI can do it better than human in this case. So this is a very simple demo for how to have do the anomaly detection. So for the RUL, we will do it maybe in the future, but not today, because that one we need to predict the CPU fan can last for how long before it totally break down. So this one we need to collect more data.
So talking about this predictive maintenance, meaning we do have a lot of data set to be collected. So that's why some of them are from, for example, this is just simple, very straightforward, the dependency, the simple, straightforward machine learning dependency on purely vibration, vibrational thing. When you talk about vibration, just now I was thinking about, you have vibration. Our heartbeat is also one part of our vibration. So actually, this kind of predictive maintenance or whatever, usually for human beings, we don't use that method to measure our heartbeat, all those things. But right now, if you talk about the what they call digital health, digital health. Nowadays, people, look at your this heartbeat, all those things. Maybe it's supposed to tell you something. But I do not know whether there is such an AI model available. I'm sure people is doing the research on that thing. Maybe not only heart. It's exactly like what our human being, all the manufacturing process or manufacturing equipment is like our not natural human being. Of course, we are talking about maybe your pressure. Your blood pressure, maybe at the production floor, the pipe pressure, heart pressure, your heartbeat, your heartbeat, the pumping, your pump is correlated to your pump, and then or your temperature, your temperature, your body temperature also, you see the pattern of temperature, your heartbeat, your pressure, some more what. Maybe your environment that you are living with, so that also can be one of them. And even if let's say some predictive maintenance requires some imaging, capture some image, looking at the image, vision AI tell you something, fit into the data set, that can be also one of the factors. There are many other factors. I think basically it talk about the let's say a pump. It's a pump, pumping thing that you cannot afford to, you are not afford to down the system. The downtime is very crucial. So, predictive maintenance will play a very important part. For example, for pump, you can have a vibration. You may want to tap on the vibration. You may also want to tap onto the temperature of the near related shelf area. Some of our customers share with us, humming, the humming,
the sound,
something like that sound, but it can be correlated to the what we call the vibration as well. Of course, the pressure, pressure of certain pipeline or something like that. That actually tells you something. And also very important thing is the energy, the power consumption. When power consumption go high, I was sharing with one of the client about the chiller. Let's say the energy consumption has gone high. Usually, certain filter or certain thing have to be, you have to do some maintenance. That is also one part of predictive maintenance. Predictive maintenance can be very small, it can be very big. So of course, that requires some domain expert, especially the manufacturer will tell you, these are the criteria where he will give you the RUL. You define the RUL for that. So of course, AI is not just play here. You see whatever. We require. It's a kind of ecosystem where you require some domain expert. Of course, you have an AI. Of course, you need a very suitable system or kind of thing to translate to you. For example, IoT. That's why all of this one is related to AI and also IoT. That's why I want to share with you on the IoT part. We have a different ways of gathering data, especially in the manufacturing plant. You may have, okay, just now I said pressure, temperature, vibration, rotating speed, yeah, and displacement. Some displacement is also count. Yeah, something wear off already, the displacement go off, just like our brake or brake pad, all these things, displacement. Just now I talked about, we say some imaging. That one is a higher level. Yeah, some image, you need to capture image and so on. These are the related data collection need to be done. Of course, with this current IoT technology, for example, in Axiomtek itself, yeah, practically if you talk about most of the sensory device or some sensors data, all can be taken care very well. Even if some people is some of the process requires some strain, strain data. We even have a strain gauge data that able to translate that. Yeah. So that is all about IoT part of it, especially talking about predictive maintenance. These are the tools required. We are specializing in creating some of the tools for you to collect data. Of course, AI, we are doing a little bit more of research, in doing more relevant or more correlation or result that able to reflect to you. Yeah, that is one part. Maybe then you have other things to share.
I think my part already covered.
Okay. So, so talking about that, I would like to share with you. Of course, every session we have something. We have some legacy thing to share with you. Last week we talked about, we shared with you about some microprocessors, which is very old stuff. Yeah, 8088, 8028, and so on. Today I want to bring up one of the things is called the buses in the computer. We are in the industrial computing for many years. Of course, in one of our Facebook posts also, I talked about the old days, during the old days, 8088. That is a time that sparked off a lot of a computer, we call it PC-based interfaces. PC-based interfacing. Wow, that time is very that word actually attract, it got my attention very strongly, especially the PC-based interfaces. This is one of the bus they started. So we talk about this is an 8-bit. Maybe Chen can give a bit of this is an 8-bit. It's an 8-bit ISA bus. Yeah. So why I want to show you this one is because last week I showed you this. Last week I showed you this. It's a PC104, also the ISA bus on the 8-bit, and then this one also the ISA bus in a different form factor. Yeah, this one is a PC plugin. What can this one do? So it's also related to data acquisition. Yeah. So last time we have this one, how you want to measure even vibration, okay? It can be voltage fluctuation, it can be some analog readings, you can use this one to convert. Okay, right after that, what is the next bus that available during the time? The next bus is going to be a PCI. You see, this one is a PCI bus. This is another bots that able to plug in your PC to do all the automation in especially early 1990s. These are the things very famous. And then you will come to a thing called a PCIe. Yeah, this is a PCIe bus. PCIe bus. These are the IO bots that able to give you the AI. AI is analog input, not the artificial intelligence. AI, and then the AO, analog output. You can also have a digital input, digital output, like what I showed you. And one very interesting thing is some buses that you haven't seen before. Maybe. Okay, I just want to show you some of you maybe, you know about all these things. Very good. So, but some of you have not seen this one before. This one is maybe about 18, 19 years old, or 15 years old, something like that. Yeah? So these are the bus that, as you can see, this one is a PCI. This one is a PCI. But what about this one? If some audience who has got some answer for it, what bus is this? This one looks like PCI, but so long. Yeah, what about this one? The chocolate color one. So these are the buses that evolved from the very beginning on the ISA bus, from the ISA bus to a PCI, and then you can have a long one, and then you have a short one, very, very tiny, that kind of bus. So that long thing, the PCI is called, I don't know whether you got any answer from the audience, maybe not. So never mind, that one I'll just show you. This is called a PCI X. Because during that time, from ISA bus, 8-bit not enough, they use the ISA bus 16-bit. Then, the data transmission so we require more throughput. So people design a PCI bus, 32-bit. Yeah, 32-bit, 16 to 32-bit. But they still think that still not enough. I want 64-bit. That PCI X actually handle 64-bit. So when you come to there, I want 128-bit, so the thing become bigger and bigger, correct? So actually the trend is going to, we are going to the nano, smaller thing or micro thing, it is a PCIe. That's where PCI Express come about. All the I/O control on the PCI Express is, this is a PCI Express by 1. Usually on the graphic card we are using PCIe Express by 16. So that is the evolution from ISA bus 8-bit to 16-bit to PCI 32-bit to 64-bit. But in order to gather more throughput, you need to expand. So they change it to the serial bus concept, or per channel PCIe, how much we can transfer. So I have a 16 channel, how much I can transfer in a serial bus concept. That was the trend, and then go until now. So I want to show you one of these board. Yeah, this is also we are on the industrial computing business for a very long time. This is a very old board. Some of you in the factory there are things still running like that. This is called a PIC-MG 1.0, the first version, which has got ISA bus and PCI bus. That is working together with some of these things, so-called backplane. This backplane is this PIC-MG 1.3, the latest one right now. Of course, I try to find some old one, just now we have, but I just don't have time to find out. Just to show you some of these concepts. Actually, it works like that. It's plucky. These are all the industrial computing concepts. Yeah. But those people who are in the IT, ICT, usually you'll be looking at some of these on factor. This is a ADX or extended ADX concept. Yeah. So just now I forgot to tell you, some of these bus is called AGP. Last time before the PCIe by 16, we put the graphic card. A lot of graphic card is designed for this AGP, just for the video purpose. That actually covered from the ISA bus very old time, 1980 something to until today. PCIe is like that. So I hope that part is you find this one interesting about this the evolution of the PC bus. Why I want to show you this one is because partly because some of the old stuff that I want to just share with you. But a lot of this data acquisition, actually came from there. A lot of machine automation PC based also started and kickstart from there, and then it's evolved into different area. Yeah. That is something that I want to share with you. So of course, we have gone to what time already? 4:30 already. Oh, we are over five something already. So usually our live session is about 30 minutes to 45 minutes. So just over just 40 minutes. I just want to share with you some of the events that we are going to run. For example, just now I share with you the Axiomtek Digi Hub. That is a QR code. If you want to join, you can join. Of course, me and 𝐀𝐮𝐬𝐭, we are the drivers for the AIoT mission, especially on the innovation, training, application, and things like that. We are also conducting some training, in the IoT and AI. You can also find us in our Facebook, if you or in this QR code, so you can find us. With that, 𝐀𝐮𝐿, do you have anything other thing to share and to add? No. So in this the whole AIoT, Sembang AIoT from first session up to now, I hope you are. Thank you for following. If you are still watching, following us, and we would like to call upon you to do, share, like, and subscribe. If you think this channel is interesting or useful to you. And for some of the young people, if you are following us, you can see some of the old stuff. Maybe that thing exists before you were even born. So I hope you enjoy. And in the AIoT mission, our motto is we innovate. Yeah, we innovate.
We train.
Okay, basically we innovate, and then we we train, and also we share. Yeah. So very important thing. Yeah, we innovate, we apply, we train, and we share. So thank you very much for watching, and I will see you in the next session. Thank you. Bye bye.
Thank you. Bye bye.